Title: Read Solomon error-correcting codes usage for biocryptographic algorithms. Authors: Velcio, Patrico, and Patricio. Source: Applied Computational Intelligence in Informatics. Vol. IEEE 10th Jubilee International Symposium. Month: May. Year: 2015. Pages 37 to 41. The topic of this article is cryptography. So, how does math strengthens the biometric system? It make use of two images to compare and obtain the genuine points to form the polynomial. It further evaluates the possible points and obtain the final vault list to help encoding and decoding. So how is this done? This is done by using Lagrangian interpolation, which is estimating function values when no precise data is given. First, let's look at interpolation. Interpolation is finding the value of y at its corresponding value of x. Moving on to Lagrangian interpolation, it is derived from the following formula, given at n+1 data points, as it starts from x0 and y0. The n in the function refers to the n-order polynomial. Example: by looking at this graph, n is equals to 3. In the formula, the function L of x is a weighting function. The values of the weighting function can be derived from the following formula. It uses multiplication method after dividing the subtraction of the different values of x, until the n-1 terms, where j equals to I is omitted. So, how do we use Lagrangian interpolation? Let's use an example to illustrate the application of it. The upward velocity of a rocket is given as a function of time in Table 1. V of t is the function of time. In the table, only certain values are given. You are asked to determine the value of the velocity at t equals to 16 seconds, using a first-order Lagrange polynomial. There is no precise data given, related to when t is equals to 16 seconds. But, from the graph and the values of x, you can see that t equals to 16, is between the plotted points x equals to 15 and x equals to 20. Using Lagrangian formula, the function f of x is the function of time, which is v of t. We need to find the summation of function L of t multiplied by the function v of t. Given that it is a first-order polynomial, n is equals to 1. The summation of this formula ends at n+1 term. In this example, n+1 is 2. So, the sum of these two gives you the values for the function v of t. Given that t equals to 16, we can make use of the two numbers nearest to 16, which is 15 and 20 to be t0 and t1 respectively. Next, we substitute the respective values of v of t. The function v of t for t0 and t1 are given in the table. So, by substituting what we have into the formula, we are still missing the values of the weighting function. Using the weighting function formula, we replace the I and j with the respective values and substitute the respective t to obtain the weighting values. T equals 16, t0 equals 15, t1 equals 20. Next, gathering all the known values into the Lagrangian interpolation formula, and we will then get the final value, which is the velocity of the rocket at t equals 16 seconds. That's all we have on this topic. Thank you for watching. This video is done by Tan Wei Hung, To Yu Jo Jabrian, and Tan Ting Wei.
Created using Powtoon.